Fine with me. Let's go ahead.
All right. Well, good evening, everyone. Welcome to EC Tech Talk today. Today's talk will be about electrical engineering at TTI Outdoor Product Division. It's a pleasure to introduce Mr. Mika and Mr. Tang. Mr. Mika is one of us. He graduated from Clemson in May 2020 with an undergraduate degree in, BSEE, and joined TTI in the Outdoor Product Division. Since then, he has performed extensive testing and troubleshooting of cordless lawn and garden tools and has multiple PCBA designs in the pipeline for production. In his spare time, he enjoys tinkering with vintage electrical and electronic equipment and working on vehicles, both of my passions. Mr. Tang graduated from University of Washington with a BSEE in June 2020, very recent graduate. Joined the same team in October 2000, same team as Mr. Mika's in October 2020. And he helps realize engineering or marketing needs by facilitating and participating in the communication across the various departments, sales, batteries, supply, etc., and works closely with various mechanical engineering groups to meet tool design parameters. Matt loves a good game of Ultimate Frisbee and is helpful for TTI intramural post-pandemic. Okay. With that, I would like to request Mr. Mika to share the PowerPoint presentation and we can get started. Thank you.
Certainly. Thank you very much for the introduction, Dr. Raza. Let's get the PowerPoint up. So as Dr. Raza said, I'm Nick. I'm here with Matt, and welcome to our Tech Talk. We hope you enjoy. So I want to give a brief overview first of TTI as a company. TTI is Techtronic Industries power equipment. We are one of the largest power tool manufacturers in the world. We were founded in Hong Kong in 1985. And we have a US headquarters in Anderson, South Carolina, just down the road from a lot of you. I know you may not all be in Clemson at the moment, but we're very close by. We have a huge brand new campus right off of exit 27. It's pretty convenient to Clemson and Greenville. It's about a half hour from either one. Like I said, big new campus. It's only about 2 years old and we're still adding on to it. So it's going to keep getting bigger. One thing to note about TTI is the company, including engineering, is largely divided into consumer power tools, or CPT, and outdoor products, or OP. We're both from OP. Some of this is also going to apply to CPT. You know, they're also definitely going to have positions open. Probably not quite as many as we will this year, but we expect that they will have openings as well. Our main brands, probably the most recognizable ones, are Ryobi, Rigid, and Hart. For us in OP, we mostly deal with Ryobi and Hart. Ryobi is sold at Home Depot. Hart is sold at Walmart. Rigid is a big brand, pretty big brand in CPT, but we don't really have Rigid OP equipment at this time. Milwaukee is also under the TTI umbrella, but they still have their own engineering and really everything facility up in Wisconsin. So we here in Anderson don't really deal with Milwaukee very much. Just wanted to get that out there. We have some other brands, but those are the big ones that you're probably going to recognize most. I'll let Matt take over here.
All right. So opportunities. What might you be doing if you are able to, secure one of the 10 plus positions that are opening in the Outdoor Products Electrical Engineering team this year? Just to give a rundown of our big EE group, we have three main subgroups. One of them is batteries. And so this deals with battery pack testing, designing the firmware, designing the hardware for the management / control of these battery packs. And then additionally, there is also a software side to this. There's the need to design desktop applications because these batteries are in-house, these PCBs are in-house. And so just, writing scripts, writing desktop applications for making much easier debugging and testing, just to assist in the calibration, the programming, and especially in the reading of usage data. One thing to know about batteries that's really interesting is that, you can't just stick, 12 lithium ions in series or something, maybe stick another 12 in parallel and then call it, a DC bus. No, you need to monitor each and every single cell, monitor each and every single temperature. And so there's a lot of opportunity for writing some really solid firmware in that respect. Next, we have the Bldc team, which stands for the Brushless DC and then motor. So these are motors that commutate using just, you magnetize some coils using three-phase inverter. I think it's, yeah. Mm-hmm. And so in the Bldc team, now you're writing firmware and designing hardware more on the tool side. So you have a battery PCBA, and then you have a tool PCBA, or more overall, a controller. And so it's their job to interpret project management specifications, whether or not it comes from, say, more of like a sales department, a marketing department, or comes more directly from management and engineering. You need to be able to interpret this and then realize these kind of schematics, realize these kind of electrical designs, and then simulate them. Additionally, there is the edge case / ESD testing. This is just at the PCB level. So zapping them with, maybe, I don't know, like 4 kilovolts or so, just as a little test, doing edge cases. And so there's that. And then there's also the tool team. And me and Nick are both on the tool team. So on the tool team, we also do firmware, hardware development for the tool control PCBAs, but now the tools are more at the level of, we don't see them anymore as just their PCBAs, but as complete tools. And so we might do ESD testing, not necessarily zapping the controller, but maybe zapping maybe like the motors, zapping maybe extra modular, I don't know, LEDs, LED displays. And a lot of our job is doing this testing, troubleshooting of controllers in a tool context, not just a PCBA context. But overall, in all three of these subgroups, there's a lot of hands-on work, a lot of collaboration between the groups. It's not like us on the tool team, we're stuck doing this. There are tons of Bldc people, working on the battery firmware. And likewise, the same for, others. So additionally, there's a lot of communication with other departments and a lot of opportunity exposed, not necessarily to just the technical side of the engineering and of the manufacturing, but also the, human side. How does project management get done? So there's a lot of exposure to that. So we'll talk a little bit about our designs. For the hardware, a lot of it can be broken down into just A or B. We have 18 volt / 20 volt platforms, or we have 40 volt / 36 volt platforms. We have brushed versus brushless motors, and then we can either commutate them, using sensored control or using sensorless control. In the case of brushless three-phase motor. And then there's also the decision to use Ryobi versus Heart. And so this actually does have hardware implications. It isn't just slapping on a Heart sticker onto a Ryobi product. There's a lot more nuance to it. And so Altium Designer is used just for the layout of all of this. In the firmware side, we all of our controllers run on the Bldc, and so for the firmware, you implement PID control. I think a lot of you guys know what that is. It's just
if you don't know, you will. Seniors probably know, I'm sure. The rest of you, you'll get there. But yeah, not everything we have does PID control or even closed loop control at all, but some of it does.
Yeah.
The stuff with the a lot of the brushless tools, in fact, possibly all of them use closed loop control.
These PID controllers, like they're very robust. The tuning process is actually pretty standardized, which I found pretty awesome coming into here, because it gave me hands-on experience with what a more industry standard kind of PID controller might look like. But there's also the open loop, direct control of the duty cycle of the MOSFETs. And so additionally, in the firmware design, whether or not a design choice is to choose whether or not you can have the PCBA on the tool and the PCBA on the battery communicate. Say the battery can send temperature data, and it's up to the designers of the tool PCBA to be like, okay, do I need this information? How will it impact my layout? Will it be too expensive? That's a big one. And in the firmware, additionally, there is the design of protections. Too much protections, your circuit ain't gonna work. It's gonna be way too slow. But if you don't have any, obviously that's gonna be a problem. You're gonna have some, super high current spike. It's gonna damage and ruin permanently your expensive battery packs and your piece and your tools. So lots of considerations. So here is just a picture of, on the left, on the top left, you can see a Ryobi 18-volt pack, and on the right, you can see a 40-volt pack. And you can also notice the ratings. We have a 2 amp hour on the left and a 4 amp hour on the right. And you can also, and so one thing to note is that the pack on the right has more cells in parallel. You would be able to, infer just by looking at the size differences. And also there's more in series. You can infer that, 40 volt versus 18 volt. And then we have the Heart design on the bottom. Yeah, those are just things to look for. Here we have on the left 2 pictures of the same Bldc motor. And on the right, we have just a normal DC motor. On the left, the Bldc, we're actually working with this really high power 1200 watt motor. This is a 1200 watt motor that you can just hold in the palm of your hand. And it's an outrunner. And if you look, I don't know if you can see my mouse, but in that middle picture, there's the opportunity to, solder in some Hall sensors. And so this is, like I said, you can do censored or sensorless control. It's up to you.
Yeah, I think the Hall sensors are, I believe they're actually soldered to this green PCBA. If you look at the far left, that little green sliver in there, the Hall sensors are little surface mount components that can read the magnetic fields off of the motor and provide feedback to the controller.
So what are some constraints that we face when designing? So not our field, but also our field, because our PCBAs take up space. Mechanical. There is a desire for these tools and batteries to be compact and lightweight. The move towards cordless, and not gas, but electric, comes with the expectation that you have a light tool that is, easy to use, that is the future. And so it's got to be compact and lightweight. And so with the controllers, yeah, this is easy. I mean, PCBAs compared to, say, their equivalents on, say, gas-powered tools are way lighter. So mechanical, that just puts a spacing constraint on the PCBA. Will it heat up too much? Sorry, yeah, we'll talk about electrical and thermal next. So electrical, maximize performance without overloading battery and budget. Now, so on a PCBA that we'll see later, we have our MOSFETs thermally connected to a gigantic heatsink. And so you could buy a MOSFET that has really, really good performance, but at the end of the day, that's going to be way too much money. And, we can't be charging our customers too much money, right? Otherwise, they're not going to buy it. So there comes the maximization of performance versus what you can, practically achieve. And for thermal constraints, the batteries, like I mentioned, they can get too hot. Your chargers, they can definitely get too hot. You can't charge too fast. There's also some battery physics, of course, with charging too fast, but practically speaking, you can't just have too hot of a battery. Your tool controller can't get too hot. I already talked about the MOSFETs. And also, motors get very hot. And so in the picture on the right, you can see that we have a fan attached to the heatsink of the controller. Now, the airflow is obviously perpendicular to the surface of the heat. And you might be thinking, hey, Matt, wouldn't it be more practical to, have the airflow going with the fins of the heatsink? And yeah, but from a mechanical standpoint, you only have so much space. And so this fan was put this way as you can see it as oh, we only have this much space. We can't do it the most practical way, but we'll do what we can with it.
And it works. So Matt talked about a lot of things, a lot of design constraints that are sort of trade-offs. We want to make a tool that's lightweight, but we want to put a powerful enough motor in it and have a powerful enough battery. So there are trade-offs to that. And of course, we have to, we can't make it cost a fortune or no one will buy it. So it's a balance of performance and cost and durability and all kinds of other things. But there are some things that we have to adhere to. We don't get to make, it's not just something we can have trade-offs. I mean, there are hard constraints on some of this stuff as well that really impacts the design. One of those is regulatory. These are external regulatory agencies like UL or TUV that you may have heard of. Basically, third parties that verify that our products and a lot of other consumer products are safe and compliant with all the necessary standards. And obviously, we want our products to meet those because it's a requirement to be able to sell them, and we certainly don't want to be putting out anything dangerous. So some of the things impacted by regulatory are part selection. Like on this diagram here, some of our applications have a power switch that actually interrupts power to the microcontroller. In other situations, there's a switch that's just a signal switch where the microcontroller is always powered and the switch just tells it to start up the tool. In both of these situations, we have to have a switch that's listed by a regulatory agency. The switch that actually turns the tool on has to be an approved switch. So it's one of the things we have to take into account on our designs. On this bottom diagram, another thing that comes into play is firmware certification. So until I worked here, I never really thought about like UL testing of firmware, but that's a thing, and it's a big thing. And anytime your firmware could have a safety impact, like the tool could fail to turn off if the user releases the switch, that firmware has to be certified in order for the tool to pass regulatory. So UL and other test agencies do go over our firmware and review that. And it can take a long time. I mean, it's a big deal for like project timelines, this regulatory testing. It can take weeks. Another common feature on our products where regulatory comes in is braking. So there are certain requirements on some tools where the thing that moves, like a mower blade or a chainsaw chain, has to come to a stop within a certain time after the user releases the trigger. And in a lot of cases, there's not enough mechanical resistance in the tool to do that. So we have to do electrical braking. In some situations, we actually do that with MOSFETs, which in turn are controlled by a microcontroller. So that means firmware certification. So that's another instance of that. Just something to consider that you don't usually get exposed to in school, but it's a big deal in industry. I certainly, it was new to me when I started here. And finally, we have some internal safety constraints as well that are just put in place to ensure we have safe products. One of those examples is this locking mower handle. We have a requirement that the handle has to be extended and these latches have to be locked down before the mower blades will start. So those are just some examples of some very important safety constraints we have. And I wanted to show a few pictures of some other designs. These are two brushless DC lawnmower motors. We have what's called an in-runner on the left, where the rotor's on the inside, and an outrunner on the right, where the rotor's on the outside. These or very similar motors are in mowers that we have on sale today, right now. And this is what a typical mower controller looks like. It's actually housed in an aluminum enclosure. I also wanted to briefly go over one of our sort of pretty standard PCBA designs that we use in various products. So hopefully you can see my mouse, but in the left photo, on the top left and right corners of this PCBA, where these Phillips head screws are, those are 6 MOSFETs. If you look on the right photo, that's a side view. You can see the MOSFETs are actually sandwiched between the PCB and the heatsink. And there are 6 of them because this is a brushless motor controller, has 3-phase output. So a lot of you, I'm sure, are familiar with 3-phase motors, and you know that it's they use a sine wave, 3 sine waves that are 120 degrees out of phase. And traditionally that would come from a 3-phase generator at a power plant. We don't have that in a cordless tool. We just have a DC battery. So we have to simulate 3-phase power. I mean, we're not simulating it. It is 3-phase power, but we're doing it using square waves and MOSFETs that are switching on and off very quickly. So 3 phases, 2 MOSFETs per phase. So each phase can be either pulled high to the positive or pulled low to the negative. You have 2 pretty standard large electrolytic capacitors. The square thing with the pins on all 4 sides, a lot of you probably recognize that as a microcontroller. That's the brains of the operation. Above that, there are some ICs which are actually MOSFET gate drivers. That's an interface between the microcontroller and the MOSFETs. So those are kind of the basic aspects of one of these controllers. So now I'd like to shift a little bit. I won't bore you with any more text and pictures. We'll switch to Matt's phone here and actually show you some tools. Give us a second. Let me stop the share. Okay. I'll mute my computer and you unmute on there.
Yes, and while they're transitioning, I'm not sure if I pin the video, if it's pinned for everyone in the audience, but please feel free to pin the video on your computers. Thank you.
Okay. Yeah, sorry for...
Yes, I think the other laptop needs to be muted.
Hello.
Yes, that's much better.
Okay, sorry about that.
No, that's fine. That's fine. Thank you.
All right. So I'll walk into the frame over here. So what we have here is a Hart 20-volt, 12-inch chainsaw. This uses a brushed DC motor. It's right in here. And got our bar and chain. This is a simple on-off controller. There's no variable speed here. Just on or off, full speed or nothing. We've got a 4 amp hour battery pack. My glasses are fogging up, sorry. Yeah, pretty standard. One of our basic chainsaws that we offer. And you might want to turn your volume down a little bit. I'm going to briefly run this thing. So that's a fun one to test out when we get to do actually cut wood with it, which is a pretty regular thing. Now moving over, we've got this Ryobi 18-volt brushless line trimmer that's attachment capable. So you can put all kinds of different heads on this. So you can have a line trimmer, or there's a hedge trimmer, there's a blower, there's all kinds of stuff. But from an electrical standpoint, we've got an outrunner brushless motor in here. We've got a heat sink controller that's potted, so it's moisture and vibration resistant. We've got an output to a variable trigger switch, so it is variable speed. And we've got a high-low speed switch as well to change the maximum speed. So this has a battery in it. It doesn't have a head attached, but I'll run it briefly. So this is a sensorless motor. So it actually, instead of Hall effect sensors, it uses back EMF detection from the motor windings. The controller actually reads that and uses it for feedback. So I'm gonna take the phone from Matt here, and he's gonna show you a couple other tools.
Over here we have our new 21-inch mower. And so one thing you might notice is that there are actually two controllers. And so these are two separate PCBAs. This one actually runs the wheels back here. It's two-wheel drive. And then this one right here is the main one, and it's for spinning the blade on the bottom. And actually, these two have a shared connection. They share a bus. Well, they share the DC bus, the DC battery voltage bus, but additionally, they also communicate with each other. And so if one shuts off, the other has to shut off.
Gonna show the drive. Yeah, let's pick it up.
Additionally, you can notice that the LEDs have not timed out. And that's only something you can do with, electrical. Can't really do that with gas-powered lawnmower. Here we have just a part blower, 40 volts.
Yeah, that's a brushed variable speed. So we've got different variations. We've got brushed, brushless, single speed, variable speed. I wanted to point out this mower handle because there's a lot going on here. We've got bail switches and a start button for the blade. And we also have a potentiometer here for engaging the self-propelled drive, and also a max speed setting for self-propelled drive. So this is pretty complex. There's a lot of design in this. I think that's it for the tools. I'm gonna switch back to the laptop and we'll go into more of a discussion.
Well, thank you so much to both of you. Excellent presentation. So very, very interesting and lots of information, lots of knowledge to absorb. I believe we have now about 25 minutes for questions and answers. Question answer session and discussion. Mr. Mika, I think you're muted. Yeah, in case if you can.
Turn that off and then.
Is this working now?
Yes, it's
Okay.
Okay.
Got it. Sorry, I just wanted to talk briefly about our sort of experiences, what we've worked on so far, before we go into questions. It shouldn't take very long.
No, please take your time. My apologies. We had to get to that. And if you can also share the contact information with students, that would be great. Thank you.
Sure. Let's see. Where's the...
So Mr. Mika and Mr. Tang, they're going to share their experience as working electrical engineers and hopefully students can connect to that experience, and hopefully that will prepare them um, well when they're starting their professional career.
I hope so too. Yeah, so I think I think we've got everything back to normal now. So as you know, I started at TTI back in May, not long after I graduated from Clemson. Since then, I've done a lot of tool testing. That's pretty typical for the tool team in OPEE. We get a lot of hands-on time with the tools. I mean, it goes for all of us in OPEE, but the tool team specifically gets a lot of use test time. Um, when I do that, it's been a lot of temperature recording voltages and currents, just making sure we're staying within safe limits of electronic components, making sure we're not overheating or overloading our battery packs. You know, we want to maximize performance, but if we're overheating battery packs before we can drain them, then that's going to be a problem for the consumer. So there's very much a balance there. Lots of troubleshooting. If we get a field return on an outdoor product, a lot of times that'll come straight to us, the tool team. So we take a look at that, try to figure out how to prevent the issue. I've also gotten a lot into PCBA design lately. Nothing crazy yet, like a new controller or anything like that, but some LED modules. I have several that I'm working on that are scheduled to go into production this year. So I'm really looking forward to actually seeing something I designed, sold on a store shelf. That's going to be really neat. It's probably one of the more satisfying parts of the job, saying I worked on that. It's a little too soon for me to be able to say that, but I should be there this year. Just as far as day-to-day life goes, I spend a lot of, and actually this goes for Matt too, we spend a lot of time at the outdoor product test lab. That's actually where we are right now. It's where we've been all day. We haven't been in the office very much since we started. Some of that is pandemic related, but we really do a lot of testing and troubleshooting at the test lab. And it's a pretty good time when it's not crazy urgent, which it sometimes is, but it's still a good time overall. There's a lot of communication between departments. So we go back and forth a lot with mechanical engineers, with product management, with customer support, very, very much going between groups and collaborating on things. We also have an engineering office in China, in Dongguan, and they help us out with a lot of our designs. They do a lot of our designs, and so we're back and forth with them a lot. We'll send them something, and of course they're 12 hours off from us, so they'll reply overnight and work on it, and then we come back in the morning and we have more stuff from them. So it's fast paced, but it allows us to really get a lot of output, and it's pretty cool. Get a lot of exposure to different things.
For me, I joined late October. So I've been here for almost 5 months, I guess. And I'd say something I've really enjoyed that Nik already brought up is just the communication with the mechanical engineers. I found that I really enjoy like obviously we're dealing with motors, BLDC motors. There's a bridge between, the electrical and the mechanical power generation. Okay, well, this is a little cheesy, but there's a bridge between the mechanical and the electricals, and I feel like we do that pretty well. Um, they have a lot of good input, um, and we're always talking back and forth about, do we have enough space to add this? Can you take this capacitor out? It's too big. So I like that. Another thing that I've noticed from the day to day is that the finished product or the finished prototype gets to us, and maybe it experiences some kind of unknown static discharge, and so at this point we have to do debugging. But besides debugging, we're troubleshooting. Okay, what kind of component can we add to this? Oh, obviously, we can add some kind of Zener or TVS. And so a lot of soldering is involved in this, at least in our side, with just, working with a finished product and then, okay, let's replace this with this. Or maybe we'll, take these two nuts and stick a TVS or something across it. And so there is a lot of testing. And then we can also test some of our own ideas. We can brainstorm. Oh, maybe this tilt sensor isn't working for some reason. Should we short the two input terminals or something and see what happens there? A lot of taking what exists, maybe repurposing it for something else as well. You can totally take a blower PCBA and apply it to maybe a line trimmer or something. Because at the end of the day, all you're doing is spinning a motor. Now, how well it works is quite variable because you have different motors, different parameters, different controls.
You might have to tweak firmware a little bit, something like that. Add a different sort of user interface. But Matt's right. It's a lot of stuff can be transferred over. That's really a lot of what we do is figuring out how to adapt one thing into another to make a new product or improve an existing one. I think that about covers it for us. We'd like to leave the last 15 or so minutes for all of you to ask any questions you have for us. We'll try to answer them as best we can. And if we can't, we'll write them down and we'll try to find the answers for you.
Okay, well, thank you so much. I think I would like for all of us to thank our speakers, and it's time for a few questions.
Sorry.
Please.
I wanted to switch to the next slide. I'll just leave this up during questions. This is our contact info. If you want to get in touch with us for any reason after this to ask us anything about positions or, more about daily life, whatever, here you go. Take a screenshot, take a picture, revisit this presentation later. Okay, I'm done talking. Dr. Raza, go ahead.
No, that's fine. This is all very helpful, and you can tell from the chat that how much helpful it was. So it's time for a few questions, and please feel free to unmute yourself and ask questions using your microphone. If you do not have access to a microphone, you're welcome to post the questions in chat, and I'll keep track of them, the questions in the chat area, and I guess I'll help facilitate those chat questions. Okay, so please go ahead.
Hello, can you hear me?
Yes, we can hear you.
Yes.
Yeah, so my question was, like, before they employed you, what kind of skill sets are expected from the TTI company to be employed?
What sort of prerequisites?
Yeah,
Yes.
yeah, the skill sets, or like, what was it the expectation from the company when they first employed you?
If I may repeat the question. So the question is that if you want to be employed by TTI, what is TTI looking for in a potential employee?
Yeah, that's right. Yeah.
I would say it's important to be skilled in hardware, knowledgeable in hardware or firmware. It helps a lot if you know both. But we have teams that are more dedicated to hardware and more teams that are dedicated to teams that are more dedicated to firmware. So if you're stronger in one and not so strong in the other, that's okay. But understanding of power electronics, I would say, know what a MOSFET is, knows, even if you're more hardware, like be somewhat familiar with embedded C, know what registers are on a microcontroller, just be knowledgeable about that sort of basic stuff. The big things are microcontrollers and power electronics. That's a big part of what we deal with in OPEE. Be ready to multitask. Be ready to have multiple projects going on and switching between them day to day or even hour to hour. We're all busy. That's why we're looking for so many people. But I think even with more people, we're still going to be busy. So I would say be ready for that and highlight those abilities. When you're interviewing. It's hard for me to speak to, really, because I just kind of said what I said and I got an offer. I can't speak for everyone else's experience. Matt, do you have anything?
If I were to say something, at least if you were to stand out in the interview, I think having a good, if you could look at our PCBA and point out, like 10 components, that'd be great. You could point out the MOSFETs, you could point out the gate drivers. I mean, if you have like the deductive reasoning skills, oh, there are these 3 ICs stuck right together, those got to be some kind of, gate driver or something. So just having that kind of like reasoning. For the firmware side, know your C, know how to shift something. Jumping back to hardware, know what a voltage divider is, maybe know what a resistor looks like in a schematic. My boss told me that, some people, they had to coach them through the interview. They had to be like, okay, well, this is a voltage divider.
If you've never looked up something on DigiKey, try looking up something on DigiKey using their sort feature. That's something we do a lot of, and it's a useful skill. And they might ask you to find a part on DigiKey.
So, time for a few more questions.
Okay. Oh, I see someone has a question in the chat.
If I may read that question. So what course, if any, would cover back EMF in the undergraduate electrical or computer engineering curriculum?
Power electronics. Took the power electronics course. Well, sorry, I come from the University of Washington.
Yeah. I would say, I'm trying to remember now, it's been a while, but I think the power class at Clemson, which one is that? 3600? The one that's
yes, 36.
the one that's all about electric motors and transformers. I think there was something in there about back EMF. And I believe also EMAG may cover it to an extent.
I think Dr. Groff is here, so he wanted to add something.
Okay.
I was just confirming that it's 3600.
Yes, and
okay.
Also confirm that it's Kyle. Thank you. EC 3600. Okay, very good. Okay, time for a few more questions.
I had a quick question.
Yes, Martin, please go ahead.
So as far as your interest in applicants, I'm planning on doing a fifth year masters here next year, would TTI still be interested in someone who is just coming out of a master's program, or are they more looking for undergraduates?
I would say absolutely. If you're coming out of a master's program, I think we'd be interested. When we were planning this tech talk, actually, it came up that a recent Clemson ECE grad alum is, considering or potentially has accepted an offer at TTI, which I didn't know about until very recently. And my boss's boss, one of our VPs of engineering was like, "Man, Nick, you should have. What are you doing? You should have brought him over here." I think he's talking to CPT. So yeah, when he was like, "Man, come on, Nick, get him over here. What are you doing?"
So master's,
Obviously, it was being facetious, but somewhat serious. We'll take, if you're in a master's program, I think there's room for you here too.
excellent.
Thank you.
Very good. Very good. Time for a couple more questions. If I may ask you, I have a long list of questions, but I really want students to ask questions. So if I'll wait for someone to ask question. If not, then I'll go ahead and ask this question. Okay, so it goes back to the first question, what TTI is looking in future employees. If you think about soft skills like teamwork or project management, how important is that?
I think it's pretty critical, wouldn't you say? I mean, you really spend a lot of time working with other engineers and non-engineers, PM, product management, things like that. So, if you've got good communication skills and ability to deal with a lot of information coming through you, coming in from people, and you communicating out to other people is great to have, great thing to highlight. I don't know, do you want to speak to that as well?
Yeah, everything Nick said is absolutely, but that's not to say that, because engineers, I think typically are, more a bit closed off and like to work by themselves. And that totally has a place here. You could, spend, hours soldering something together, looking at a schematic and figuring out, okay, where do I need to put this TVS or something? A lot of this, there's a place for both being a social butterfly and then, being someone that can just work on something by themselves for many hours.
Yeah, I agree. Even if you're not a big socialite, we've got people here like that. Some of us regularly deal with ME, product management, customer service. And some of us, pretty much just write firmware all day. I don't want to make that seem like that's insignificant, because it's not. I mean, we've got some very skilled people who do that, who are in fact much better at a lot of things than I am. But not everyone has to communicate with a bunch of different groups at the same time. So I would say don't be scared by that. You'll probably have to communicate with other groups at some point. I mean, that's kind of part of engineering, as a lot of you have probably figured out. But yeah, don't let that. I didn't mean to scare you off with that. Communication part of it, because there's a lot of people who just they don't really have to do that in their day-to-day work nearly as much as some others do.
Very good. Very well. We still have some time for questions.
I have one.
Okay, please go ahead, Benjamin. And there is another question in the chat area. And after we answer Ben's question, I'll get to that question. Thank you.
All right. I was curious, what were some things that you could do outside of the class that would help prepare you for an industry job and, you know, maybe look good on your resume as well?
Very good question.
What do you think? Well, if you don't learn how to solder in your coursework or senior design at some point, you're going to be ahead of the game if you come in knowing how to solder well.
I think this job specifically looks a lot for PCB work. I know it's really tough to be motivated to, I got to find a personal project. But I encourage you, maybe you could just design some kind of simple Arduino. I don't know. My house is really cold. I've been thinking so much. Maybe I'll just like make a controller or something that just manually moves like the temperature control, the temperature dial or something, and then just does that control for me. It could be something as simple and dumb as that, and you'll have something to talk about and be passionate about. You'll have something to stand out with in your interview. So I'd say for EE, I would think a PCBA design would be good. You get the firmware, you get the hardware.
Yeah. Also, if you do anything that involves like microcontrollers or robotics, motor control, if any of your hobbies align with that at all, you're gonna be able to apply that to power tools and lawn and garden products. I mean, there's a lot of overlap there. Even just like if you just generally work on electrical and electronic stuff in your spare time, there's a lot of common skills there. Yeah. I would like to get to this question in the chat because that's a good one.
It's more like a follow-up question to this question. So let me read that question for everyone. Is there anything that you wish, I'll add, you would have been or would have been included in your school's curriculum that would be useful to you at TTI?
Yeah, so I probably my big one is I wish the C programming had lasted later into the curriculum. And I think I actually mentioned this on my sort of exit survey when I graduated. At my interview here at TTI, I was asked to do some, write out a blurb of C code or a couple blurbs. And to be perfectly honest, I didn't do very well at all. And well, I'm still here. They still let me in. And I've always been more of a hardware guy. I've written plenty of code, but I'm by no means like an amazing programmer. So that's probably why I ended up on the tool team, because tool team is much more hardware focused. And I'm very happy here. I think it worked out great. It was a good fit. But yeah, I didn't, the C programming stuff in the interview kind of took me by surprise a little bit. I mean, it shouldn't have, I guess, but I struggled with it more than I would have liked. So that's something, and the C programming stuff at Clemson, like, yeah, you get a lot of that in microcontrollers, but that class focuses heavily on like setting registers and you know, bit shifting and that kind of thing. All great stuff to know, very applicable. But, you know, just sort of basic C programming skills like sort algorithms, not really covered in microcontrollers. That goes back to like the CPSC 111. That's like freshman, sophomore year. I wish there was more of that kind of more advanced C, besides just microcontroller specific stuff later in the curriculum. It would be good if, you know, if you're rough on that, might not be a bad idea to just brush up on it a little bit. That's just my suggestion. I know you come from the University of Washington, so it's, I don't know if you have anything you want to add.
I think Nick covered it all. Yeah.
All right, so it's 6:30, and I think we can keep on, if Mr. Mika and Mr. Tang are available, we can keep asking them questions. But I would like to take a moment, because I understand that students and faculty or staff may have to leave because of prior commitments. So I just wanted us to take a moment to thank both of them, especially Mr. Mika, for taking this initiative to come and talk to us. And so let's thank both of them, and we can continue asking questions. And yeah.
Yeah, I can totally stay for a little bit longer. And like we both really appreciate all of you working with us, Dr. Raza, Dr. Groff, Dr. Kapadia, if you're on. And of course, all of you students, it looks like we had a great turnout, and we really appreciate that. From all of us here at TTI and OPEE, we're really happy to see this, and we hope we can keep doing things like this, maybe even in person. You know, there may be further developments here.
Yeah, feeling is mutual. Feeling is mutual. And I would, Dr. Shaw is here, and I would want you to introduce you to him, both of you to him as well. And I know we have talked about site visits potentially this semester. So something that if we can come up with a protocol, and if we make it work, that will be great.
Right. Thank you, Hassan and Nick and Matt. Thanks very much to bring this wonderful, lectures and experience to our students. Nick, you are our own graduate, and Matt, you are from somewhere else. But I think this is this is quite important, right, to our students and to our faculty as well. I think I heard a lot of the things that we are doing well, and there are things that we can do better. But I think lectures or talks like this is something that this department is actively pursuing. To let you know that I have scheduled a meeting with some of your TTI leadership, with the dean, with Atu, and he's a department chair of mechanical engineering. So the meeting is next Wednesday, and we're going to talk about strategic collaborations between Clemson and then TTI. And things like this is wonderful, right? And we really hope that you can help us and then get our students to the best job in the world, right? Mm-hmm. And also, we will be glad to help you guys, to kind of, align our students for whatever the opportunity that's available. All right, thank you very much. I'm going to jump off, but again, on behalf of the department, thank you very much. And I hope that we can do this more often and maybe face to face.
Absolutely. Thank you so much.
Right,
we really appreciate it.
Hassan and Rick and then Apua, thank you very much for organizing all these. This is wonderful. So I'm going to jump off. Thank you.
Great.
Thank you.
Thanks. Have a good night.
Right.
If anyone has any closing thoughts or questions, feel free to ask.
So does anyone have any questions? Okay. If you don't mind taking a question from me, so is there a mechanism for like, so question is really about ergonomics or ergonomic design. So for example, the vibration of that you have in the tool, does that convey any information to the user? If yes, how do you design it?
So
You mean like a phone in that it like vibrates instead of like makes a sound to give like a notification?
Did you say phone?
Yeah, like because you were talking about how like vibration would like give a signal. So
Yeah,
like if it vibrates.
right. So I did not have like a separate device in mind, like a phone, but really, let's say one of the lawnmowers or blowers, do you design for somehow the vibration signal to be used as an ergonomic feature to convey any warning to the user?
to my knowledge, we don't do it. I
Okay.
mean, that's a really good idea. I'm curious now if anyone's ever brought it up here. That would be very clever to do. But I have not seen it in a product yet, to answer your question.
Okay. All right. Yeah, I'll be happy to be part of that discussion if I'll be curious as well.
That'd be cool.
Right. We still have time for a few more questions. I think if there are no more questions, let's thank the speakers and great talk. Thank you so much. Thank you.
Thank you, Dr. Raza, and thank you all for attending. We had a great time, and I hope this was helpful to all of you.
No, it was great. Very, very, very helpful.
All right.
Yeah.
Oh,
We'll stay on for
Oh, wait,
another
wait,
minute
wait.
or two, but
Rick, what's up?
I would have a question that I've might get into the weeds. Are you able to tell us what sort of simulation software your BLDC group uses?
We likely just use LT Spice. I know in my power electronics course, we use Plex for more of like a power electronics focused kind of thing. Currently right now at our small level, because our group isn't too big, but there's a lot of responsibility on everyone. We currently use LT Spice, but I think more robust simulation would make life a lot easier, not just for the electrical engineers, but also for the mechanical engineers.
Right, something that was a multi-simulation, so better included forces and so forth.
yeah, I would have to ask around to see if they do anything like that, like you know, electromechanical interaction. I'm sure there's some of that going on somewhere, but I don't, you know, that's not something we work with on a regular basis. So let me make a note of it and I'll ask. I'll get back to you.
That would be great. Thank you. Another question. So the microcontroller hardware that's in your equipment, I missed. I apologize. I came in late. I was on carpool duty at 5:30 at the
No
last
worries.
minute. What sort of variety of different microcontrollers and so forth do you use? Do most tools use the same sort of what sort of selection is there?
I mean, we use a variety. You know, I don't want to reveal too much, but I mean, you could figure out who we use for micros just by unpotting some of our controllers.
Right.
So
Like we use,
ST's a big one. Most of our newer stuff is 32-bit ST. We also use some smaller Asian vendors for certain PCBAs.
Okay.
I think there's like an Infineon, no, or is it an Infineon? There are like some chips there were some chip choices that were like way before probably I even started college or something. And now like the code to that has been lost to the sands of time or something. Really?
I haven't been exposed to that too much.
Yeah,
Oldest stuff I've seen here is probably STM8 based, which we can still, talk to and do stuff with.
Right. How much do the legacy methods and legacy hardware influence day-to-day choices for you guys?
I would say, I mean, I feel like we do a lot of new development. I mean, I don't think we really limit ourselves very much based on what we've done in the past and the kind of hardware we're already building. I mean, I haven't been here that long, but it feels like new designs are a regular thing. I mean, of course we reuse plenty of stuff where it makes sense. But if we need something that we don't have, we'll design it. We're not, we don't limit what we can do with a product because we don't have electronic hardware made for it. If we want to make a product, we'll get the electronic hardware for it one way or another.
Nice. That gives some nice opportunities to you guys as design engineers as well.
Mm-hmm.
That's neat.
Yeah, it's not just little incremental improvements to 10-year-old boards.
Thank you. Those were my two big questions. I just want to say again that I think you did a really nice job with the presentation tonight. It went really smoothly, and it was a lot of really nice information.
Well, we really appreciate that. We know there were a few little technical glitches, but yeah, overall, I agree. I think it went pretty smoothly, and I'm glad you agree.
Yeah, I could not agree more with Dr. Groff, and those small technical glitches. I mean, they're all right. I guess they're there all the time in each and every seminar. So no big surprises. So, but job very well done. So if I may ask one more question.
Sure.
You mentioned UL regulatory testing.
Mm-hmm.
You have to do any of these FCC regulatory testing to make sure the electromagnetic emissions from the electrical equipment are within the constraints?
I mean, it's pretty loose, I think, relatively speaking, for the US market. It's a bigger deal for the European market. They're more stringent on that sort of stuff. But it is a factor, and obviously our stuff can't violate any kind of radiated emissions rules. But overall, it's probably, the stuff we make for the US market, which is the bulk of what we design here, radiated emissions is not really one of the bigger considerations most of the time.
All right. Okay. And well, I said that my last question, but I have another one if you have a minute.
Mm-hmm. Sure.
So, and this question may not be, I mean, you may or may not be the right group to ask this question. But have you seen what they call system engineering? Any of that incorporated in the practice at TTI?
System engineering.
You know, there is project management, right? I
Mhm.
mentioned it over and over again.
Right.
Yep, yeah, but there's also what they call system engineering. And I was wondering if that's something, doesn't look like it's part of everyday practice.
Yeah, it's not a term we really use very much. I mean, we have electrical and mechanical, and they obviously work closely together, but system engineering is not something I've really heard thrown around very much. That's something I could ask around. I could, ask people above me,
Right.
specifics about that. But yeah, I don't encounter that on a regular basis.
All right. Okay. Well, thanks for answering those questions. I believe we still have, thanks to Mr. Mika and Mr. Tang's generosity with time, we still have some time to ask questions if anyone wants to add to the discussion. I think this is it then. Well, thank you so much. I could not agree more with Dr. Shaw and Dr. Groff that this was very helpful. And from the turnout, you can tell there was a lot of interest. I think this is probably one of the biggest seminars or talks that I've seen. So,
Wow.
yeah. Dr. Groff, would you agree?
Yeah, I think so. You can fit a lot more people in a room when it's virtual.
That's true.
That's true. And people can join at their convenience.
Yeah,
Okay.
which is a strength of this format that I